Thank you, Patrick, and good morning, everyone. Now, the construction site and its machines is what we're going to focus on a little bit now. I work mostly with contractors in my daily life, but I understand that there's a lot of consultants in the room today. And the most common question I get when I talk to you consultants is, are the designs we produce being useful and are they being used? From a machine perspective, the answer is yes, increasingly so. Now, I've been with Trimble since 2004, always in this civil construction industry, always around machines and sites. Before that, I did some stints in the startup businesses for some e-learning systems, and we also did some interactive web-based demonstrators for the telecom business maybe. I started my working life in surveying for a Swedish company called NCC. So I've been in and out of this construction environment positioning and some development for my entire work life. So today I'm going to talk just briefly about, like Patrick mentioned, the machine. I'm going to give you some examples of some machines that I think are quite nice. We'll present to you where they are today in terms of intelligence. I will then talk a little bit, just a quick glimpse at two contractors to see what is the most important thing for them around machines. And then I will end with some quick thoughts about the future. But before we start, I just want to stop at this word intelligent machines, because I know that may be a bit confusing. Now, certainly for me, some days it feels like these machines are more intelligent than I am. But I understand that that is not true from your reference point maybe. So if you struggle with this word, think of them maybe as connected machines, technically advanced machines, or ideally highly productive machines, because that is what they are or strive to be. So there are a lot of machine brands and a lot of machine types, and you see a few of them flickering by here. We Trimble produce systems for all, or not all, but many machine brands and many machine types. And all of the machines you see here can be equipped with some sort of technology. So I'm going to start here with this beautiful thing. Now, this is a CAT D6 dozer. It is as capable as it is powerful. And it's also amazing that despite the fact that it's been pretty much looking the same for the past 100 years, it's also one of the more intelligent machines out there. I also mentioned this machine because this is where it started for us in terms of machine automation. The dozers and also graders were automated in the early days of machine control, and it was a slow start, of course. Operator didn't need help to guide the blade. They knew how to do that. But eventually it took on, and today it's more or less standard to have these machines automated. I say this because we are at a similar crossroads today with another machine, but I will get back to that. So these are the key pieces on this machine from our perspective. On your right, you see some connectivity devices linking this machine up to the cloud. In the middle, you see the screen where the user interfaces with the system. This is also where the design resides, of course. And then the machine has a lot of sensors. And you see two of them up on the blade there, the GNSS receivers. For this specific machine, they can also be on top of the roof. But this machine also has some other features that may or may not be linked to the control systems that we in Trimble typically, or I at least, typically am interested in. It has very nice joystick integration so that the operator does not have to lift his or her hands off the controls. The machine can be operated from the joysticks, of course, but so can the control system to a certain degree. Very nice integration. The second thing I wanted to mention that I think is nice as well is something called auto carry. If you push a load with a dozer over a distance, it may be hard to maintain the proper amount of material in front of the blade. That happens automatically on this machine. Same for the rear. The ripper is automated to optimize its use and also to minimize the wear on the machine. A cool feature that can be enabled to assist the operator to protect the grade. If in auto mode, the blade does not go below grade, but in manual mode, this, when it's enabled, can also help the operator to not dig into the design and create a hole that should not be there. Of course, loads of emission control technologies, both with this brand and with many other brands as well. There's a lot of investment going into this, and I don't mention them further here, but it's a clear drive to create cleaner and leaner machines that leave a lesser footprint on the environment. And last but not least, I also wanted to mention this thing. It's called auto shift technology, which basically enables the operator to set the speed of the machine, and then the machine takes care of the power, the torque, the gearbox, so that if it pushes hard, it has all that power it needs, but if it pushes light, it goes back on power. It maybe it changes gear, so that the machine is always working at its optimum. I'm told that this could reduce the emissions with up to 20%. Now, if you want to cruise through Copenhagen in style, this might be the machine you would choose. This is a cool compactor from Dynapack. It is interesting to me, or I'm puzzled by the fact that these machines are not more equipped with technology than they are today. It makes a lot of sense, I think, to have a good command over your compaction, because it's such an important piece of the civil project. Now, in terms of technology, the pieces look the same. They usually look the same across the machines. They can actually be interchanged between the machines as well, both the machines within the type but also outside of the type. So you can put the dozer system, essential parts from it, on a compactor, on a grader, and so forth. So these machines are usually very simple to operate, but they're very hard to do a proper job with, because once you pass the surface once, it's flat, and you can't see if you pass that surface once or many times. And usually you want to have 4 or 5 passes over a surface. So machine control is very useful, because it essentially turns the operator to a painter, and he just uses the machine as a paintbrush and paints that design. Brown maybe for the first pass, red for the second, blue, and then when he reaches green, he knows he's been covering the whole surface. Also, while doing this, the machines can register the CMV values, or the energy that goes into the ground and comes back up, to measure stiffness of the soil. And when done, contractors can simply go back and find the weakest spot and take their measurements on that spot. And if it passes, they should be fairly confident that the whole road is, or site, or whatever they do, is good. These machines can also do as-builts. They're quite good at doing as-built data, because they're usually on the ground. It's rather unusual that these machines are up in the air, unlike some other machines where the blades can lift and so forth. So they're uniquely good at taking as-built data when they do their final pass over an asphalt layer, for instance. Equipped with the right accurate sensors, you get amazing data from this machine. So this beautiful ballerina, this is an excavator, and it's hard to be here in Scandinavia without talking about the excavators, because they are so common. But I also think, at least from my standpoint, these machines, the excavators, they are not as different as some other machine types. An excavator from brand A seems to me very similar to an excavator from brand B and brand C and so forth. I'm sure the manufacturers would say otherwise, but when they're used, when their technology more capable, it seems to be more like tools that they add to the machines. But I think this will change also for this machine going forward. I also mentioned this machine because it's quite interesting for us in the civil business. This is the first machine where we have just launched our new grade control, our new machine control platform. It's called the Earthworks, and of course we knew that this was coming, and I kind of expected more grunt in the computer, more processing power and so forth for handling those bigger designs. What I didn't expect, and what surprised me, is the significant improvement on the sensors on these machines. It's quite remarkable. It's not just better, it's better to a factor of 10, which is exciting, because this enables us to do other things with the machine, like automation. And I'm going to tread careful now, because this is just in the start, but we have done some early studies, and it seems that not only is this system operating the way the machine driver wants, it also seems to give the performance that the site manager needs. So it's both fast and it's accurate. So here are a few studies. Take this with a pinch of salt, please. But here are a few studies that we've done. And if you look at the study number 2 there, you see a 50-meter batter slope with a normal machine control system, guidance only. it took 32 minutes, and then when enabling the autos, it took 16 minutes. Of course, material operator skill and things will impact this. But a significant increase or a decrease in time, but also if you look on the lower right there, an increase in accuracy. So it went from okay to quite good within that golf ball accuracy that we're trying to get. So those were the machines. If you want to have a further chat around those machines, I think we have friends from CAT here. We have our paving and compaction specialist here. We also have SciTech here, so go out and watch these new excavator systems and talk to them. They have great knowledge, and they would surely like to show you this new and exciting system. So what about the contractor? Well, with all these modern machines, you might think that the office of a contractor would look like the control tower of a spaceship, right? And correct. That is what they look like today. Contractors are more and more being wrapped around technology. And this, since we're here in Copenhagen, this is a Danish contractor called Barsland, their office. And when I talk to these larger contractors and ask them what is the most important thing when you have these increasingly intelligent machines around you, the answer I seem to get is the design. Good quality constructible models seem to be what they put a lot of effort in getting or creating, depending on the quality of the data they can get their hands on. I also asked Barsland what more they appreciate with these new and techier machines. And another thing they mentioned was the fact that the machines are connected. It's easier for them to get designs and design upgrades out to the machines these days, and that means a lot for a bigger contractor that has many machines apparently. So what about the smaller contractor? Is that a space cowboy that lives half in this world and half in this other? Augmented reality? Yes, that's the case. This is Fredrik from FMT, just across the water here in southwestern Sweden. Now he uses technology mainly to visualize things for his customers, because unlike the bigger contractors, his customers are non-professionals. And I think we in the room here are a little bit unique in that we can look at the 2D drawing and envision what it would look like in 3D. Most people can't do that. And he deals with bankers, accountants, sales clerks, people outside of the business. So it's a huge tool for him to be able to take the customer, put on the glasses and step into the design together with them, to agree on the premises of the job, set the right expectations, and then hopefully get the contract signed. And then when that happens, he simply passes the models over to the machine, of course, his small machines, being a small contractor, and goes to work. Now, I said smaller machines. It seems that these control systems are increasingly appearing on smaller and smaller machines as well. So I ask these small contractors, this is a relatively high cost for these less pricey machines, the technology piece I mean. Is that useful? And the answer I get is not only is it useful, it may be more useful on the small machines than technology is on the big machines, because smaller machines sometimes operate in more expensive material, and they sometimes create more complex designs. So I think the trend we see is that it's going down in size to have machine control system equipment machines. I also asked Fredrik what he appreciates more with this technology. And also Fredrik mentioned the connectivity, but not from the shuffling data perspective, but from the fact that the machine dealer could get to the machine. They know where the machine is, they know where it needs to be serviced, and they just come service it, and Fredrik doesn't have to deal too much with it. He thought that was a great thing, and I thought that was neat as well to hear, because when we started this, we had this kind of big brother is watching you fear. But it seems that a lot of small benefits come from this connectivity or the connected machines. So what's to come in the future? Well, I think that's what we're here about today. The design, the model is going to become much more important in the next few years, I think. And hopefully we're going to get those few gaps that we still have between the beautiful designs that are being made and the designs that we see in the machine. A better flow there between, I think, and hope will come. And then maybe you've seen some of these press releases flickering by lately, or maybe you haven't. It seems like a few years ago there was just one or two or a few manufacturers that had technology from the factory or technology preparation from the factory on machines. It seems today most machine manufacturers have some kind of technology program of their own, preparing machines for machine control, or actually building their own machine control systems. From where I can see today, these programs, these technology preparation programs seem to come in 4 levels. The first basic one is just that the machine is equipped with some brackets, maybe some holes or drills, so that the machine control systems just become a plug-in and routing the cables kind of activity. No painting, no welding has to be done in the field. The second level of integration is one that I personally think is very good. By the way, there are many manufacturers that do this first level of integration. The second level of integration is the same as the first, but also adding the cables, maybe integrating into some joysticks, and if it's an automatic machine, maybe preparing for the automatic control as well. Liebherr is an example of a machine manufacturer that does this level of integration. The third level we're starting to see is everything hardware from the factory, only the software piece and maybe the infrastructure piece is missing. Volvo is an example of that kind of system. And then finally we have, and this is not a preparation, this is a full machine control system from the machine manufacturer. Everything bolted on, ready to go. And Caterpillar is a good example of this level of integration, or this. So what about further into the future? Well, then things to me starts to get a little bit daisy, but I'm very optimistic about this augmented reality that I think we're going to see a bit more of here today as well. It's just so helpful out in the field to be able to see the design in a better and a more useful way. Augmented reality, I think, is going to come quicker than we realize. It's just amazing. Of course, we talked about it already. Machine automation is increasing, and eventually autonomous machines, I think, are going to start to appear. And then the environment, of course, that's important these days, and a lot of these improvements around smart machines benefit the environment. But I think that maybe when we meet here again in 5 to 7 years, the environment around civil projects might be the main topic. And last but certainly not least, I think that the constructible model increasingly will become the hub around which all of this intelligent equipment on a site is being wrapped. So much more information can go into that design than is happening today. So with that, I just wanted to show, let's see how this works now. I just wanted to show 2 quick film clips. The first is an example. This is a non-released product, so you can't go buy this yet, but it's kind of in its testing stages. But I think it shows in a very good way this augmented reality that I talked about. And I also think it again highlights the importance of the design. The second film that I wanted to show is this new automatic excavator system that I also mentioned. Exciting times for us, and you also see how that is guided against this, again, important design. So let's see if I click here, if Aren't we starting to get somewhere? I don't know what you think, but I think this is super cool. So this second movie is about the Trimble automatics system.
Operating an excavator efficiently relies on highly skilled and experienced operators. Without them, jobs take longer to complete and are more costly. With Trimble Earthworks, your excavator can now work semi-automatically, so operators can create smooth, flat, or sloped surfaces with ease. When in autos, the user controls the stick and Trimble Earthworks controls the boom and bucket to stay on grade. This added precision and control prevents overcut and increases production. The Trimble aftermarket hydraulic assembly, compatible with a variety of manufacturers and sizes, taps into the machine's hydraulic system while maintaining the original response and feel of the joysticks. By partially automating the highly skilled task of creating smooth surfaces with an excavator, Autos allows operators to work smarter, faster, and more productively. Ergonomic controls also enable the operator to leave a high-quality surface with less joystick motion and mental fatigue at the end of the day. It's just one of the ways Trimble is transforming the way the world works. Learn more by visiting us online or talking with a dealer near you.
So before I leave, I just want also to point out that these two customers that I talked about, Barsland and Fredriksmark from Sweden, are here today. So if you want to have a chat with them, they're great to talk about how they use design models and intelligent machines. Grab your Trimble shirt nearby and ask them to introduce you. So that's it. Thanks a lot, guys, for being here, and have a great 2 days.